can also be added to precipitate out more aluminium hydroxide. This process is called seeding. Sometimes I normally like asking under aluminium, what do we mean by the term seeding? Seeding, as seen here, is a process of adding pure crystals of aluminium hydroxide in the mixture of sodium aluminate, sodium silicate to precipitate out more aluminium hydroxide. So it's an industrial process, not much of chemistry we run at this point, but there is that alternative process that is carried out called seeding. So seeding is that addition of pure crystals of aluminium hydroxide. The other one, the first one, is bubbling carbon 4 oxide. So again, under this, confirm the products, but one of them is aluminium hydroxide. So bubbling is a reaction for aluminium hydroxide. When we writing an equation, we show the aluminium hydroxide crystals on the arrow. So in both cases, silicon 4 oxide, which is as sodium what? Silicate, is left in the solution as a filtrate. So it is not just silicon 4 oxide, but sodium, sodium silicate. Probably you can change this to sodium silicate. Yeah, that way. It remains in the solution as the filtrate. Sasa tumepata aluminium hydroxide yetu. Ignore this aluminium 3 hydroxide. It is just aluminium hydroxide. Aluminium iko na valence 3, so hiyo haichangingi. We only use these numbers to show when the metal or the element have more than one oxidation state. The next step is roasting, whereby we heat aluminium hydroxide to obtain aluminium oxide. So remember, mwanzo tulikuwa na bauxite, which is what? Hydrated aluminium oxide. Hydrated aluminium oxide. We could not heat directly that bauxite because of impurities. That's why you have gone through that process of concentrating the ore to remove what? To remove the impurities. So. Okay. So from there, we heat the aluminium hydroxide that we have filtered out to obtain aluminium oxide. That's a aluminium oxide. This is now what we'll carry out. We'll heat to melt it, and in the process of melting molten aluminium oxide, we feed it into a special structure called Hall cell. Hall's cell, which is a cell, which is the name that is given to this cell whereby we extract aluminium. Hall cell, from this subtopic here, extraction of aluminium from bauxite in the Hall cell. In Hall's cell, not the spelling, Hall cell. So from the cell used to be called the process, Hall's process. This is a person who came up with this structure, hence the name was given. The process name was given according to the person who came up with the structure there. Hall's cells. So in a manner pia Downs cell ya sodium pia kuna jamaa alifanya kutengeneza hiyo structure ya kuseparate. So that means you have down cell, you have Hall cell. So that is in the electrolysis process. Okay, so then this melting point of aluminium oxide, we can see it is around 15 degrees centigrade, and a lot of energy is going to be required to melt it. We add molten cryolite. Molten cryolite acts as an impurity. It lowers the melting point of aluminium oxide to about 800 degrees centigrade. Molten chloride, or the chloride, which is the industry name, it is the chemical name is sodium hexafluoroaluminate. Sodium hexafluoroaluminate. You note the formula of this chloride, Na3Al6 chloride. At this point, you don't ask for formula, but in case but hatujaipata swali linaulizwa uandike formula ya chloride, no. We are only interested with the impurity that is added during extraction of what? Aluminium. So tunaona melting point inashuka from 15 degrees centigrade to what? 800 degrees centigrade. Okay. Let's see in the process. Chemical reactions that takes place. How does this hull cell look like? The hull cell is made up of a steel tank, which is lined with carbon, graphite, an anode of carbon graphite suspended into the electrolyte. So after melting that aluminium oxide, we feed it to this electrolytic cell, whereby the anode is suspended in this electrolyte, inside the electrolyte. Electrolyte sasa ndio hiyo sasa molten aluminium oxide. During electrolysis, but before that, let's look at the structure itself first. This is the hull cell. Let's look at the various parts of the hull cell. See where various substances are. So I've said that this hull cell is made up of a steel tank, whereby inside there is the graphite, which forms now the what? The cathode. That is where we are going to connect the negative terminus of the source of current. And then suspended, there is this bar on top here, whereby inside that is where we have these rods that are suspended, and inside on the top part, and I blue pale up to there, is space yote, it is filled with molten electrolyte. Inside there is molten what? Electrolyte. That is aluminium oxide. Then bottom, this level blue, there is aluminium zinc what? To the bottom of the hull cell. So hapa juu tuko na nini? Tuko na the molten electrolyte. Then hapa chini tuko na the aluminium, molten aluminium. What does that tell you? There is a difference in density. So ina maana aluminium, molten aluminium, which is tapped at the bottom, is more dense. Is more dense than the electrolyte. So electrolyte ndio iko pale juu. Sasa, so tumeona on the side ndio tuko na nini? This graphite, which is forming what? The cathode. And then there is the other side, the lining forms the cathode, which is the graphite. Then suspended on the electrolyte, that is where we have what? The anode. So note that structure, and then try to look at the reaction which are taking place. Where is oxidation? Where is reduction taking place? Note that I'm giving there is an oxygen gas that is being liberated at this point. Tunaona oxygen pale. Ina maana oxygen inakuwa liberated around what? The anode. Okay? Oxygen from oxide ions. So the oxide ions are oxidized around the anode. But then again tunaona hapa kuna CO2 gas. Hii CO2 gas inatoka wapi? Naonyesha inatoka pia kwa hizi anode. Okay? As we discussed, tutaona ya kwamba as oxygen gas is being produced, the anode is made up of graphite or carbon. So, at this temperature of around 800 centigrade, the oxygen that is being produced as it is being discharged around the anode, it reacts with what? The carbon which is making the anode. That's why inaonyesha hapa kuna CO2 gas inakuwa liberated. There is a precaution in a question that we ask. State one precaution taken during extraction of aluminium. In the hull cell, one precaution taken is regular repressing of the anode. Ile ulikuwa umesoma? Good. Madrid, naona ulikuwa unataka kujibu ile swali, lakini ni sawa. Yeah, running. So I was saying that this anode should be replaced regularly because huwa zinafanya nini? Zinaisha, zina reduce in size because of reaction with the oxygen gas produced. Precaution, not always precaution when to prevent something dangerous. Yeah, so therefore note that. As we go to the chemical process, that is the equations for the reactions. Just a minute. Tulikuwa hapo sasa kuangalia the chemical process that takes place. Now give me a minute, make a call. So what we are interested with is to know the equation for the reaction that takes place during electrolysis, that is in the anode and in the cathode. But tumeona anode, oxygen inakuwa produced. That means cathode, aluminium inakuwa preferentially discharged. Note the way we balance. Note the way we balance those equations. It is important that we make sure the number of electrons that are lost in the anode are the same number of electrons that are gained in the cathode. There are two types of questions that are asked. You write equation for the reaction taking place in the electrodes. Also, write equation showing reaction taking place in the electrodes. Those equations must be balanced, like these ones. Sasa, umepata hiyo swali ya kwanza? Write equations for the reactions taking place in the electrodes. Zinafaa kukaa hivi. They must be balanced, same as we have, as it is shown here. Listen, the other question. Write an equation to show how products are formed, or write equations to show how the products are formed, or write the equation to show the products formed in the electrodes. You write equation to show the product formed in the electrodes. In that case, we only need to show the equation to show how, or to show the products that are formed. But ile swali ya kwanza, you're supposed to write equations for the reactions taking place. So hiyo time lazima to balance the what, the equations. Lakini swali ingine ya write equations for the product formed, or to show the product formed. You're only interested to show an equation that is showing what the product is being formed. For that one, you don't require to balance. You only need to show if it is aluminium, you only show one aluminium gains 3 electrons to form one aluminium. Okay? So you don't have to write the 12 electrons. You just put the equation showing what? Formation of one aluminium atom. Yes, Shem.
Excuse me, sir, please may you repeat the question that requires you to not to write only the ions for each of the ions.
So the two questions are, you write equations for the reaction taking place in the electrodes. Hiyo ni swali ya kwanza. Hiyo unahitaji uonyeshe balanced equations. Na hiyo equations zitakuwa tu kama hizi. You start with the anode so that you can understand it well. You see one oxygen loses 2 electrons. But aluminium requires how many electrons? 3 electrons, okay? So that means for us to get another electron for the first aluminium to gain the 3 electrons, you require another oxygen. Then another oxygen loses 2 electrons. Sasa ina maana 1 electron yenye inahitajika na aluminium inakuwa gained na what? Na the aluminium atom ya kwanza. Sasa so hiyo inajaa hivyo. Okay? Lakini the second atom of, the second oxide ile ime lose the 2 electrons. Kuna moja yenye haijakuwa gained. Sawa? Hiyo moja inaenda wapi? So lazima we require another aluminium. That other aluminium itafanya nini? Itachukua hiyo 1 electron, okay? Lakini haitakuwa stable, isn't it? Itakuwa imebakisha ngapi? 2. Sasa hizo 2 zitatoka wapi? So we require another oxide to supply. So that is the first type of question. The equation must be balanced. The second question is, write equation to show products formed at the electrodes. So for that question, write equations to show products formed. You know, you only need to write an equation. Kama ni cathode, aluminium gains 3 electrons to form what? 1 aluminium atom. Sasa your time you only require 3 electrons, not 12 electrons. Sasa. Okay, so probably we shall look at those questions later. Question.
The question is the aluminium formed in liquid state?
It should be in liquid because we are dealing with molten. There is no water. It will be in a liquid state. Mem. James,
How do you balance?
So kindly, if you write down, see the number of electrons that are going to be gained, those that are going to be lost. As in those electrons that are lost in the anode, they should be the same number of electrons that are gained in the cathode. Can you try to write down? Yes, and then?
If you balance the second question, will you be penalized?
If you balance in the second question, you will not be balanced. I mean, you will not be penalized. It will be very much okay. So I was saying you do not require to balance for that other second question. Okay.
Okay.
So I think now that time is up, we want to conclude our lesson. By looking at the other part. So hiyo ya aluminium nimeelezea why it is on the lower or the bottom part, it is denser than the molten. Tukasema oxygen huwa inafanya nini? Ina react na anode. That's why it has to be regularly depressed. So there is this general flow chart to show how aluminium is extracted. Mwanzo tumesema tuko na bauxite. We crush ile powder, tunaweka hot sodium hydroxide. Then we filter because tunajua tutakuwa na nini? Sodium aluminate na sodium silicate, those are the formula there. Then on the other side residue tutakuwa na nini? Iron 3 oxide. Then kwa hii mixture ya sodium aluminate tunaona tunafanya nini? Tuna bubble carbon 4 oxide. Then we carry out filtration. So one side tutakuwa na sodium silicate, itakuwa kwa solution. The other side tuko na aluminium hydroxide. So continuation of that flow chart. Aluminium hydroxide, which is as the residue, is heated ndio tutoe ile to obtain aluminium oxide. Then from there we melt aluminium oxide, we add chloride. Aluminium oxide molten is taken to the hull cell for electrolysis. So then pure aluminium sink in the hull cell where oxygen gas is produced at the anode. So we are supposed to look at uses of aluminium. We know some of them and their properties. It is important because the questions zenye huwa tunauliza is a property and the use. Kama inatumika kutengeneza aeroplane parts, right? Duralumin, ile ni aeroplane body parts, harder and has high tensile strength. Making utensils, it is right and a good conductor. Overhead cables, it is right, ductile and good conductor. Thermite process, production of chromium and so forth and so forth. Okay? So make sure you relate the property and the use of that metal. So I want to end the lesson there so that you take time, you prepare for the next lesson. I hope it has been a good lesson, interactive one. We had around 160 something students joining. I hope in the next session, that is tomorrow, we shall continue there. So from tomorrow, we shall look at iron and copper. Iron and copper, so that we can continue the syllabus. So at this time, until the next lesson, have a nice day.